Alright, so right here we are going to look at hydrocarbons that are a little complex. So by complex, you can see there are a lot of extensions on this one. So let's just go ahead and get started. We first, as we already know, we want to find the parent chain. That means the longest chain. Well, the way I have this oriented, probably is going to be the straight thing here. So let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. That was close. But we can see that right there, there's one extra. So that's probably our longest one. So we said 13. So that was 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So 13 is our long chain, right? And then if we take a look here, we see that we have an alkyl here, we have an alkyl here, and we have an alkyl here. So on this one we actually have 3 different types of alkyls. This single carbon, this double carbon, and in here 1, 2, we have a triple carbon alkyl. So this one will be fun. So let's give it a shot. See what we can come up with. Move that up for you a little bit. So long chain 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. 13 carbons equals tridecane. Okay, so the parent chain is going to be tridecane. And we see here there's a methyl, so let's see here. If we count from here, 1, 2, 3, then this would be 4, 4, 5, 6, 1, 2, 3, 4, 5, 6, 7, 8, 9. Count from that direction, we have 3, 4, 6, 9. 1, 2, 3, 4, 5. We count from that direction, 5. This would be 5. So we would start with a higher sequence. So it was pretty obvious that we would start right there. So there's our carbon 1. So there's carbon 2. There's carbon 3, carbon 4, carbon 5, 6, 7. Hang on a second. 1, 2, 3, 4. Oh, sorry. I marked 5 in the wrong spot. Easily fixed. So there's 4, here's 5, there's 6, 7, 8, and then there's carbon 9 with a constituent group. So off to the side, if we write what we've got here, so we have an ethyl on, it looks like 3 and 6. So we've got a 3, 6, and there's 2 ethyls, so that would be diethyl. 3 and 6. There's a methyl on 4. And we see here on 9, there's this 1, 2, 3. We know that to be propyl. So we just want to put them in alphabetical order. E comes before M comes before P. So we're going to want to put this in this particular order here. So that means we're going to have a 3, 6 diethyl, and then we're going to go with the 4 methyl. Then we've got the 9 propyl tridecane. There we go. And that one was it wasn't really that bad if you think about it. Just a lot of extensions. So we've got 13 right here plus 3 more. That's what, 16, 17, and then you've got those 4 there. So there's a total of 21 carbons in this. So if we were to think about the chemical formula, that would be C11, right? H, and remember we know that these things follow a formula of CnH 2n plus 2, right? So if this is 11 here, 2 times 11 would be 22 plus 2 would make this, we know, H24. That would be the straight chain isomer for this one. So not too bad on that. Let's just say let's come up with a hypothetical situation here. All right. Let's just say hypothetically we were to put like some double bonds throughout this thing right here. Then this thing would essentially have a very similar name, but we would have to start giving priority to the double bonds. That's all. So since we've already started numbering on this side, if I were to put a double bond, say right there, the double bond would get the priority in the numbering. So we would actually have to start carbon 1 here, not here. Okay. So again, remember, double bond would get a priority instead of the alkyl groups. So really the only thing that would happen would be that it's a possibility the alkyl groups could be on different number carbons if the double bond is placed in some other region. So let's say for instance, oops, sorry about that. Let's just say, let's go ahead and do something like that. We've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So we had 1, 2, we had an ethyl on 3. 1, 2, 3, 4. We had a methyl, right? And then there was 4, 5, 6. We also had an ethyl. 7, 8, and then 9. There was a propyl. So that was 1, 2, 3. Well, let's just say all of a sudden, I don't know, I'm going to make this up. We can see here, here's a carbon with 1, 2. We know there's 2 hydrogens on this, right? So let's just say there's a double bond right there. From this carbon to this carbon is double bonded. All right, let's just say that's the case, right? All right, from right there to right there. So right there's a double bond. We know we would still start from this side here. We would number this, we know 1, right? So let me take this out. We know this is carbon 1, 2, this is carbon 3. We know this is carbon 4, 5, there's 6, 7, 8, and then there's 9. So if we look at this, everything is pretty much the same that we had before, except we need priority given to this thing here. So this is still a tri-dec carbon, but instead of tridecane, we would call this tridecene. We would change it to that. But now what we need to know is exactly where is the double bond on this 13 carbon molecule. So there's a couple ways of doing this. So we see the double bond starts on 4. So one way to think of this is a 4-tridecane. A more common way to accept this is tridec-4-ene. So tridec, so this is 10 and 3, there's your 13, and on the 4th carbon, there's the double bond. So both of these are acceptable names. You're going to find that this particular pattern right here is very, very useful to use, only because it keeps this together, and the number here is specifically close to this suffix, this ending, which I think can make it a little easier to understand. But if you were to put 4-tridecene, that would be acceptable. So let's look at this now. We know we have an ethyl on 3 and 6, so that'd be 3,6-diethyl, right? We know we have a methyl on 4, so that's 4-methyl. we know we have the propyl on 9, so that's 9 propyl. And then we could either write 4-tridecene or tridec-4-ene. So we've got, let's see. So yeah, well, I'll just do it that way. So we've got, the way we first learned in class, we could put 4-tridecene, or we could, again, rewrite all this, 3,6-diethyl, 4-methyl, 9-propyl, tridec-4-ene. And this gets very helpful when we have multiple of double bonds. It gets very helpful to keep these numbers really close to that. So either one of these would be acceptable. And this is a lot. Just remember, you use dashes to essentially separate every single component. It's just a rule of thumb. As you get to the next part of the name, just use a dash. And then the only time using commas is if you have multiple branches on the same carbon, or multiple branches of the same extension. Otherwise, this would look like 36-diethyl. It would look like you have 2 ethyls on carbon 36. So that's what we have to be careful of. All right, hope that was helpful. If you have any questions, be sure to ask me. Contact me by email or ask questions in class.